Okay guys, I just found out today that IM3 is starting to get into the binomial theorem, and I got so excited I decided I would start and make some more videos with the binomial theorem. So anyways, here's binomial theorem part 1. Now here we have a bunch of as you can see, binomials with powers on them, right? And hopefully everyone agrees anything to the 0 power is simply 1. You should know that. Anything, it doesn't matter what it is, anything to the 0 power is 1. Now what is x plus y to the 1? Well, isn't that just simply 1x plus 1y? What about x plus y squared? So in red I'm going to do the math down here, but I'm just going to go ahead and take x plus y times x plus y, and if you multiply this correctly, guys, now I'm going to shorten the video. I'm actually going to do this in my head, okay? But if you actually multiply that out together, guys, you will get x squared plus xy plus xy plus y squared. And notice the two terms, like terms in the middle there. So my final answer is 1x squared plus 2xy's plus 1y squared. Now normally we don't have to write those ones, guys, but I'm doing it on purpose on this time. So notice I end up again with 1x squared plus 2xy's plus 1y squared. Now what about x plus y to the 3? That's the next expression right there, right? Well, isn't x plus y plus 3, now I'm just going to go to a new page here, but isn't x plus y to the 3rd power just simply the same as x plus y times x plus y squared? Well, we already know x plus y squared is x squared plus 2xy plus y squared. And so all I need to do now is times that by x plus y. So I'm just going to do x times x squared, x cubed. X times 2xy, 2x squared y. X times y squared, a 1xy squared. Now, of course, I distribute the y. Y times x squared, putting x first. I'm going to get a x squared y. Y times 2xy is a plus 2xy squared. And finally, y times y squared is a y cubed. Sorry, I ran out of room over to the right of the screen there, guys. But we have some like terms here, right? First of all, we have x cubed. That's by itself, but we have an x squared y here and another x squared y there. So 2 plus 1 is a 3x squared y. Likewise, we have a xy squared here, another 2xy squared there. 2 plus 1 is 3xy squareds. And finally, at the end, we have a y cubed. So again, I'm just going to write this down over again on the previous page. Pause the video right now if you need to. Okay, so here I go. So, we figured out that x plus y cubed turned out to be 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed, right? Now the whole point of doing this, guys, is hopefully you notice a pattern with the coefficients. Notice I have a 1 here, then it goes 1, 1. And then it goes 1, 2, 1. Then it goes 1, 3, 3, 1. And so let's put it all together here. This is what we call Pascal's triangle. Pascal's triangle goes 1, then 1, 1, then 1, 2, 1. Again, I'm just doing what I highlighted here in green, right? The coefficients. And then finally, it goes 1, 3, 3, 1. Now, if you look at Pascal's triangle, guys, you'll notice that there's a pattern here. Okay? The pattern, of course, is, let me go to red here, is notice how we have a triangular shape, hence the name Pascal's triangle, and each row of the triangle, follow the green going across, always starts with 1 and ends with 1. Well, what about the 2 in the middle there? Well, notice how the 2 is the 1 and the 1 above it added together. Notice the 3 right here is the 1 and the 2 added together. This 3 is the 2 and the 1 there added together. So could we not keep making a larger Pascal triangle? Could we add another row on the bottom here, for instance? Of course we could. If we follow the same pattern, we know it's going to start with 1 and end with 1, right? We also know that the 3 here and the 1 there together make 4. We also notice that the 3 here and the 3 there together make 6. And then finally the 3 with the 1 there makes 4. And there is our next row. Now pause the video if you need to, guys. Now could we go on to another row if we needed to? Why not? What's it going to begin with, guys? A 1, right? And then it's going to end with a 1. 1 and 4 make 5. 4 and 6 make 10. 6 and 4 make 10. 4 and 1 make 5. And there's our next row. Now guys, hopefully you now know Pascal's triangle. It's a basic pattern. And I could keep going on and on following the same pattern. Okay? So anyways, I'm going to stop the video basically right here, guys. Right now, we now know Pascal's triangle. In my next video, I'm going to use Pascal's triangle. Okay? And that, of course, will be Binomial Theorem Part 2. Until next time, bye.